Hey guys, so this is going to be the last set of notes for chapter 9 prior to taking the quiz on it. And this is 9.6, area of composite figures. So we're going to talk about those and kind of work through a couple examples. Oops, not composite, composite figures. So let's start off with a definition. What on earth do I mean by composite figures? Oops, try that again. And so it's a figure, so that means one, made up of two or more two-dimensional, so flat, figures. So I'm going to take two shapes, or more than two shapes, and I'm going to create a new shape out of them. So, how on earth do I find the area of a composite figure? Well, we only have certain formulas, and they are just single shapes. So, what we're going to do is we're going to split the shape into two or more shapes. That you can find. The area of. So in other words, you're going to look to see if you can break it into a combination of squares, rectangles, triangles, parallelograms, which we don't generally see them in these, but you never know, or trapezoids. So it wouldn't just be one of them, it would be more than one. Now, I've actually seen kids break down trapezoids into smaller shapes and then figure out those areas and so on. So then, once you split the shape into two or more shapes, then you're going to find the area of each shape. Find the area of each shape. And then, now this is the weird part. There's so many different ways to solve these problems that sometimes you're going to use adding to solve them. Sometimes you're going to use subtraction to solve them. Sometimes you're going to make your shape look like a different shape by adding a teeny bit on it and then removing it down the line. And then sometimes you have shapes that have the same overlapping piece. So you have to get rid of the overlapping piece. So I can't tell you you're always going to add or you're always going to subtract. It could be in any combination. Then find the area of each should be shape. Each shape, and then the last thing you would do is add, subtract, because it depends on the problem, the individual areas together. Okay, and I am going to just tack this piece on. There usually are multiple ways to break the bigger shape into smaller shapes. So just to let you know. All right, I'm going to go to the next screen because I want to do my examples. So the directions are going to ask you to find the area of each figure. So one of the things you have to be mindful of when you are trying to break your big shape into smaller shapes is, do you have enough information to figure out the area? Sometimes they don't always give enough information. Sometimes you might think they don't have enough information, but you just have to remember things like opposite sides of a rectangle are congruent or have the same measure, things like that. So let's draw this shape. So this is going to be the fun part for you guys, is drawing the shape. Now, the other thing I'm going to have to forewarn you is don't trust what it looks like, trust what it says, okay? Because sometimes the numbers don't seem like they match with what you see. So from here to here on the bottom, that whole bottom is 12 feet, that whole right side is 4 feet. This portion, this straight portion, that's 8 feet. Let's see, what else do I know? This side is 10 feet. Okay, and let's see. I think that's all that I have. All right, so there's lots of different ways to do this. I could try to split it like that way and to make a big rectangle and a triangle. And here's how I would do something like this. So I'm going to call this number 1. So I'm going to color code this. So I would have an area of a triangle. Actually, let's do a shape. Plus the area of a rectangle. Okay. Now, I need to know some information about the triangle. I already know how to figure out the area of the rectangle. That's going to be 12 times 4, because those are the 2 dimensions. It goes all the way along the bottom is 12, all the way high is 4 on the right side. So then remember on the left side it says it's 10 feet. Well, I know that this piece is 4. And 4 plus what equals 10? That would make it 6 there. All right, but I need to know another dimension. That looks like a height, because that would be a right angle. And then let's see, what else are we going to do? So it goes 12 all the way across. The part on the right says 8 feet, so that means the part on the left would have to be 4 feet. Okay, now I have enough information to find the area of the triangle. So I would have 1/2 times the bottom base is 4 and the height is 6. Okay, so then I'm just going to do the math and then see what I come up with. So I get half of 4 is 2, 2 times 6 is 12, 12 times 4 is 48, 48 plus 12 is going to give me 60. Now, the label would be area, so it's going to be square feet. Okay, let me show you a different way that you could solve this problem. So this will be the blue method. So the blue method would be, I have a rectangle, so area of a rectangle, and then on the other side I have a trapezoid. All right, and this happens to be a right trapezoid. So let's see if I have enough information. Let's see, on the rectangle, the top is 8, the bottom is 8, the right is 4, so the left would be 4. So now with the trapezoid, the top base is 4 and the bottom base is 10, and now I need to know the height. Well, just like we did before, you can see that red 4, I'm going to put a blue 4, because that would also be 4. So let's see what we get on this one. So the area of the rectangle is 4 times 8. It doesn't matter the order that I write those. And the area of the trapezoid, oops, try that again, is going to be 1/2 the sum of the bases, so that would be 4 plus 10, times the height, which is the 4. Okay, so then I get 32 plus 1/2 times 14 times 4. So half of 14 is 7. That gives me 32 plus now 28. And if I add those, I get 60 square feet. So this is what I was talking about, that there's more than one way to solve these. Okay? So now what I'm going to do is just kind of show you some strategies on some unique problems. So this next one, you're thinking, oh, this is going to be easy. It's a square or a rectangle. I can do rectangles. But all of a sudden you see a piece that's out of it. Arg! So this is 5 centimeters to the edge of that. Let's see, we've got 10 centimeters on the left, 7 centimeters on the right, 7 centimeters, or on the bottom, and then 7 centimeters on the right. Okay, so let's think about this. So I'm going to show you a particular strategy. Now you might see, and I'm not going to do this one, but you might say, well, this looks like a trapezoid and a square. So we could figure out the base would be 7, and then we could figure out a height. So if we go 7, and then it's supposed to be 10 on the left side, then that could be a 3, and then I could use it that way. But I'm going to not do it that way. I'm going to do it, I'm going to go ahead and remove all this. And what if I do this? What if I add a little corner there so that it's one huge rectangle? Okay, so I would do the area of a rectangle, but I'm going to have to get rid of that shape I added that doesn't exist, because only the black lines are of the shape. So that would be a little triangle I would have to get rid of. So I know the area of the rectangle is the 7 times the 10. But now let's see what we get here. So I'm going to have to figure out some information. So across the top, if I went all the way to that corner right here, it should equal 7, but I know 5 of it. So that means this part has to be a 2. And then from top to bottom would be 10, but I know a portion of it is 7, so that means this piece is 3. So here's your right angle would be that corner, right? So I'm going to do 1/2 the base times the height. Okay, so let's start solving it. So I get 70, half of 2 is 1, 1 times 3 is 3. So I have 70, take away 3, and that would give me 67, and then I'd have squared centimeters. Okay. So the next thing, yeah, that's it. That's how we could solve that problem. So that, they call that, oh man, I forget what they call it. There's a name for it. Of course, I have to come up with these funky names, right? All right, I think I'm going to go on to, no, I'll fit it in at the bottom. So the third one I had mentioned before, and that was having an overlap happening. So I have this rectangle, and I have another rectangle, and the rectangles overlap. So he's like, okay, well, if I just figure out the two rectangles, I've got the area. The problem is both rectangles count this shape right here, so it gets doubly counted. So we're going to have to remove that. All right, let's get some numbers in here. So we're told the left side of the top one is 12. Let's change it. Let's make it meters. And then the top is 12 meters, so this one is a square. The bottom one has a length of, oh, there I go again, 15 meters, and its width is going to be 12 centimeters. Oh, there we go. Oh my gosh, I'm having trouble here. Now, they also give me a little bit of information. So on the top square, from the right corner to where the other rectangle shows up, that would be 6 meters from here to here. And then they also tell me that on the bottom guy at the top, from the edge here to this edge here is 8. Okay? So now what I can do, and again, you can't trust what it looks like, you got to trust the numbers. So on that top of the bottom rectangle, it's supposed to be 15 all the way across, and we've accounted for 8 of it. So we are going to have 7 meters for this piece. Okay? Now, let's look at the top rectangle. I know the left side says it's 12. On the right side, it says I can see 6. So at the bottom of that overlap piece, that would also be 6. So how I would set this problem up is that I would have the area of the square plus the area of the rectangle, and I would subtract the area of the shaded rectangle. Now I shaded it, it didn't come that way, but I recognized that that guy counted twice, so I'm going to have to get rid of it. So when I do the calculations for the square and the rectangle, it's going to count that 7 by 6 section 2 times. So the area of the square is going to be 12 times 12. The area of the rectangle is going to be 15 times 12. And then I'm going to subtract from that the area of the shaded rectangle, which would be 7 times 6. And again, I could put the numbers in the different order. I could make it 12 times 15 and 6 times 7 because the commutative property of multiplication says I have the right to do that. So I'm going to go ahead and do the math, and I do remember that 12 times 12 is 144. I don't know 12 times 15, so I'm just going to do it over to the side. I get 180, so that's 180. And then I'm going to subtract 7 times 6 is 42. So order of operation says take care of the math as you go from left to right. So I'm going to add 144 and 180. And let's see, let me do it this way. So I get a 4, I get a 12, I get a 3. So I get 324, and now I'm going to subtract 42 from that. So I'm going to do that off to the side. A lot of off to the side on this problem, huh? So I get a 2, I get an 8, and I get a 2. So my answer is 282 squared centimeters. All right, so we discussed breaking it into smaller pieces, kind of gave you a couple options. Number 2, there is more than one way to solve this problem, but the option I wanted to share with you was to add a piece to make a recognizable shape, then take away that piece I added. And then the other is if I overlap, I count the overlap part twice, so I need to remove that overlap once. Okay? All right, good luck with this, guys. Talk to you soon. Bye now.